Every AI agent today has a setup that can be improved. A private key saved in a .m file loaded at startup and hold it for the entire agent session. That means it can sign anything, any chain, any amount, any contract. You're trusting the entire judgment of your LLM to manage your balance. And I think there's room for improvement for that. Today, Arbitrum developers, we are talking about the open wallet standard. The issue isn't that agent needs a wallet. Actually, they do. We're at the beginning of the new agentic economic era, and the problem is how they hold and what they hold. When an agent holds a raw private key, there's a couple of things to improve. But one definitely is unconditional signing authority. One misunderstood parameter, one prompt injection, and it can move anything it can break. And this is the default architecture for all the frameworks that are deploying agents. Raw key, same process, and no policies to stop that. Here's what is actually happening. We can separate two things in here. From one side, we have what the LLM sees, and on the right side, we have what the runtime holds. So on the left side, we have the context window, and basically would be like the system prompt, the conversation history, the tool call results, and that's it. The agent doesn't have any idea of what the private key is, or even that it exists. On the other side, we have at startup, like the .m file that you have on your code. That means your private key of the wallet, your OpenAI key that initializes the LLM client, your Alchemy key. This is everything loaded at the beginning, and is everything sitting in a process heap, in a process of your user, and for as long as the agent runs. What happens is that the LLM can directly read that process, but what can it do is this agent can call some other tools that actually grab this information and use it for signing and for fetching information, etc. So the attacker doesn't need to steal your key, doesn't need to read your key. It just needs to put a malicious instruction somewhere so that the agent is reading. So if, for example, you are fetching a web page and your agent executing what has read, or you have a response from an API, or you have somehow convinced your LLM to perform, I don't know, a send transaction with malicious code, you as an attacker have never entered the context window and the LLM never saw any private key, but the result is that it can perform any bad action with what is sitting in your environment file, and your funds are gone. A few days ago, MoonPay, in collaboration with Arbitrum and other projects and foundations, has released the Open Wallet standard. This is an open standard that is unifying how agents interact with wallets. And the core idea is that the agent never touches a private key. So what it gets instead is a scope token, a credential that can be used to request signatures within some rules you have defined up front. So under the hood, we could say that we have three layers. This diagram is something like we can use as an orientation. It's not super accurate, but you could see we have three layers. On the first side, we have a vault, and that is the wallet vault. Is encrypted in the file system under .ows directory with the same algorithm as the key store v3 format that Ethereum has been using since 2015. So you have one encrypted wallet file per wallet. And this is basically how it would look like. Now going back, what we have as well is the access keys, right? If we look at here, we have tokens. This can be misunderstood with agent token, but it's not here. We have the access keys where we'll have the API key plus the encrypted wallet secret. We have as well defined here API key secret, what policies can be used for, and at the same time, you can see here how you could define a policy. So this is a very simple one that can be used as, this is a policy definition that can be either declarative or more complex. So declarative would be like allowed chains that we have, expires at. If we want something a bit more complex, like on-chain simulation, external API calls, or other complex business logic, we would need to make it an executable. And in the middle, what we would have is an agent access layer. So we would have here the decryption capability. So this is the possibility to resolve from any token that the agent is holding, to resolve it and enforcing policies. So if we have defined here some policies, and we have the scope tokens or the API keys that we have defined in here, we have this middle layer where it matches if it fits or not the request from the agent. And at the top, what we have is the interface that the agent is seeing. And we can see that we can use it as an MCP, as SDK, but very important to know that we can use it as well through CLI. And that means that the agent doesn't need actually to call any signing library, doesn't need to import more and have more context that it needs really. So what it will just run a command that it will be like sign transaction. It will use the same ticket or scope token that we have given. And then it will ask to our policy engine to decrypt the master passphrase, let's say, and sign that transaction and get it back pending the scope token that we have given. So with that, what we achieve is having OWS, so Open Wallet Standard, living in a separate and ideally isolated process that makes the agent having no signing capability on its own. So we will have to ask to the policy engine to actually sign that specific transaction or interaction that we want to have. And if the agent is compromised, the keys are not, because you have these policies that are filtering the requests. So let's do a walkthrough on this CLI and see how this works. So first of all, and the first step would be to create a wallet inside our file system. One thing that I don't really like about doing it on my machine, but this is how it works right now. So we have the Arbitrum agent treasury, and we will have here the creation of the wallet and all the other EVM and non-EVM path definitions and so on. So we have the mnemonic encrypted and save it to our vault as we have defined. And then what we can do is create a scoped API key. So our agent can sign autonomously whatever instruction he or she wants and without using the private key. So first of all, what we will do is create the policy. Here we have an example of one policy. For example, we have the Arbitrum DeFi agent that it's created at this timestamp, and we have these two rules that are not executable, are just allow change with Arbitrum 1 ID, and then we have an expiry date that is at the end of the year. So what we'll do is let's create this policy, which has two rules. Perfect, policy registered. And what you can do now is create a key for our agent, right? So we have here, we can create one key named Cloud agent with this wallet that we have created, that is the Arbitrum wallet, right? Let me double check, is the Arbitrum agent treasury. And then we have the policy that we have registered just right now. We can set up a passphrase, and then we have this key that is for our agent. In our case, what we'll do is copy it, and we will use it for signing one transaction. And then the chain, if you see, is incorrectly set up. We have defined Ethereum, but then on our rule, what we have here is the EIP of the definition of the chain ID of the Arbitrum 1. So let's put the correct wallet. And then if we try to sign, we say, hey, policy denied, because this is not in our allowed list. On the other hand, if we define the same rule, but we change the chain to Arbitrum, of course, now we have our signed transaction. So this is pretty easy, pretty straightforward. Okay, and we have one more thing to showcase here. We have created an expired policy that actually is in this field over here, and we have defined that the timestamp, from the past, but you could use this as a way of saying, I want my agent to manage, I don't know, 0.1 ETH during 1 hour, go do whatever you want, any swaps, any policy, you're free to go. So if you want to strength or say, hey, you can only trade for 1 hour, you could define it here. In our case, we have already defined this policy, and what we can do is say, let's use this new key that we have for him, let's put the correct chain using the correct wallet, everything good, and this is a transaction that we are using, like a mock transaction. But when we try to sign with our key this transaction, in theory, and it's actually what happened, we don't have access to that wallet because it's the API key that we are providing. This ticket is expired. So we just saw how easy it is to sign transactions with the Open Wallet standard. We can see this is the right direction. Local first, policy gated, no third-party dependencies. That's exactly how agentic wallet architecture should look like. In my opinion, I think there's still room for improvement for using these wallet integrations for production, but definitely this is the path to follow. For Arbitrum developers building DeFi agents, building treasury management, or anything handling real funds, this is how to give your agent a wallet. I want to see more of these integrations and how you evolve it and improve it in the next Arbitrum activities and activations that we're doing for founders. See you in the next one.